Welcome to EVMMAX Implementers call number 4. And today on the agenda is basically the client updates and open questions, plus the previous task list that we had from Implementers call number 3. So let's get started with the client updates. Is Radek here? Radek, do you want to start?
Yeah, so regarding some additional use cases of using EVMMAX in EVM1. So recently I started working on the implementation of some algorithm to which is the signature verification from the ZK-Nox team. They have some implementation in Solidity, and I started implementing their primitives in EVMMAX, and today or yesterday I was able to finish the first primitive. It wasn't simple recently because I was also kind of busy with EOF arguing topic, but finally I implemented this, and the results are kind of promising. I shared already them with the ZK-Nox people on Telegram channel, so it looks like I need to confirm, but basically it looks like we are able to compute the same algorithm, which in plain solid, sorry, not plain solidity, but using inline assembly Solidity, it costs like 2 million gas. We are able to implement this like less than 50K thousand gas. But the final results and everything with the code size and gas cost and also CPU time benchmarking, I will be sharing probably early next week, together with this Poseidon results I shared earlier. So I will share a link. But yeah, so that's what I did recently regarding EVMMAX.
Yeah, that's super cool. So it's basically about a 40x improvement. And this is also assuming the gas pricing model is sort of overestimating the cost of EVMMAX. I mean, we don't know because we haven't checked, but it seems like it's over priced.
So now I just convert everything to integers of the size of 256 bits, which is very inefficient. But I will prepare the version with, but because this modulus for this exact signature is like 2 bytes. But internally it's represented in EVM1 as 256 bits, but it's very easy change to apply, which will just use at least 64 bits integers, which should be much faster already. And of course, this implementation still doesn't use the SIMD instruction or processor instruction set. So it's also but this is more related to basically to the CPU time, not the gas cost, of course, but basing on the CPU time spent on this computation, we will be able also to adjust the gas model for this kind of small integers. So yeah, so it should be even better than this, but we'll see. So basically, I need more time to implement the rest of 2 very simple primitives and then prepare proper benchmarks and change a little bit the EVM1 implementation for small numbers.
Yeah, this is great. Yeah, and thank you for sharing that as well.
Yeah.
Cool. Do any other clients want to give an update, or just anyone in general?
Looks like everybody is preparing now for the ACD call.
Okay, that's fair enough.
On that topic, would we want to say that EVMMAX is relying on EOF for the gains that we have just heard? So I assume that for an version of EVMMAX without the immediates, that would not be 50K, but 50K gas, but like what?
Yeah, so
Couple of 100K gas probably.
Sure. I would like to honestly to be absolutely sure about the gains between the version of the which utilizes stack EVM stack a lot and between the version of EVMMAX with immediate arguments, which requires EOF, at least in opinion of most of all the Epsilon team members, but not only. So basically, I will if it depends on the result of today's discussion on ACD, but if we'll end up in not our favorite scenario, that for example, if EOF is rejected or something like this. So basically immediate arguments, introduction and instruction with immediate arguments will be very difficult in our opinion, not because of the technical problems, but because of the security reasons and pushing this kind of EIPs through the ACD process. So basically, I will prepare also the benchmarks and the version with stack, with arguments to the instruction taken from the stack, and we can compare it. But from my experience, it looks like we have most of the efficiency gains from avoiding using stack related operations. And yeah, but I need proper benchmarks.
But, yeah, but I mean, like roughly,
even if you mentioned that there is a big chance that EVMMAX will be so inefficient that it will be basically useless.
I mean, but roughly you will need seven pushes for every arithmetic operation, correct? Because there's
yeah. You can also try to use some duplication, dupes or any other or swaps. Yeah. But yeah, basically, in worst case, you need
right.
7 push 1 in opcodes. Yeah. But they are all, at least at the moment, they all cost free gas, I think. So.
Yeah. So I mean, 21 gas versus whatever EVMMAX charges is probably a big change.
Yeah. Yeah, definitely, especially for small integers, where the cost of the multiplication of the small integer, the amortized cost of the multiplication of single small integer is much less than 1, basically. So, yeah.
Yes, I mean, cost per mole is up to 12, so that's much less than 21.
For vectorized mole. Course. So it depends how big is the vector, but basically, yeah. That will be the overhead on
it will be
instruction. So
it will be huge. Okay, good.
It will be huge comparing to the cost of the instruction itself.
Yep. Thanks.
Cool. Okay, so I guess the one thing we can get to next is just the to-dos from the last time and just see how they're going. The first one was implementing the inversion opcode. Did we get to that, or are we pushing it back?
No, we didn't. I didn't have time to add this PR to this to EIP, but I will actually. I was focused on this benchmarks and implementation, and didn't have time, and other things, and didn't have time to go through the to-do list actually. So.
Okay, yeah, that makes sense. Okay, I'll say the other to do, and I guess it's also not done, and we can just push it back after you have like the Falcon benchmarks. The other one was to collect numbers using SIMD for Poseidon.
Haven't done
I
it
guess.
also,
Mhm.
yeah.
Okay, this makes sense. And then there was one by Powell, but it seemed to be optional, which is like, can we replace the precompiles? Powell's not on the call, so I'm gonna guess this hasn't.
Pavel also was kind of busy with different stuff recently, so he didn't have time. But maybe yeah, I can ask him personally about an update, and he would, if any, he will share on EVMMAX channel.
Right. Okay, that makes sense. And the other one, which was to just ask the L2s sort of what algorithms they'd like to see. From the people that I've sort of surveyed, it's basically just Starks that they mostly care about, but I haven't sort of asked the optimistic rollups. I can also ask them to see if maybe something would help them. Yeah, and those are all of the to-dos on here. Well, yeah, actually, I did say ZKL2s, but I think, yeah, it'd be good to ask the optimistic rollups as well to see what they think. Cool. Yeah, so we can go to the open questions part if anyone has any sort of open questions at the moment. I guess one meta question I have is this still on track to be put into Glamsterdam? Is that still what people want?
I don't know that we can answer that today, but I think we do.
Yeah, I'm still in favor to adding this in Amsterdam, but yeah.
I think what's needed is a lot of his spec. Go ahead.
Sorry, no, I'm finished.
I think what is needed is a fairly locked-in spec by the time Fusaka goes live on mainnet for us to be in Glamsterdam. So I think what we should focus pushing towards is getting the spec down rather than getting a reasonable implementation, at least one client. I don't know how complete we need to be across multiple clients.
Mm-hmm. Yeah,
we don't even know the Glamsterdam timing either. So.
Yeah, exactly. I have also will be sharing some feedback outcome from this this signature name. I always forget what's the name it was.
Falcon 512.
Oh, sorry. Yeah. I wanted to use this. I remember that I have to somehow. That's somehow related with Star Wars. Doesn't matter. Okay, so basically, I have also some feedback from this process of implementing this, and it looks like probably some instructions which do some kind of shuffling on the registers would be very useful here. Now I just use to shuffle the input from the loaded from memory. I just used add modx instruction with one argument being 0. But some kind of shuffling instruction, probably similar to the SIMD instruction shuffling, or maybe some simpler ones would be good to have. But yeah, I will have some better feedback when everything will be implemented and published. So yeah.
Okay, cool. Yeah, I mean, I don't know about adding just shuffling. It seems like we're partially moving down to sort of the SIMD API. So yeah, maybe it's possible. Be good to see once the report is made. In terms of having it done in one client, do people have a preference for like the first primary client that just shows EVMMAX?
I think because we have some already implemented version in GAF, maybe GAF will be a good option to start with. But
okay, that makes sense. So GAF, yeah, so we probably need to assign resources for someone to work on the GAF implementation, we can do that offline. Cool. Yeah, any other questions people want to discuss? If not, we can keep it short because I know that the ACD is probably going to be a bit interesting today for people in this call. Okay, cool. If there's nothing else, then we can just end it early. Thanks for coming, guys.